Recording in progress.
Okay, so today I'm going to finish up section 4.3 in the fundamentals of math. This was our lesson for yesterday, but I was having some technical difficulties. So we're going to go ahead and get started on page 157. Let me go ahead and get my screen shared.
Recording.
Okay, so let me get my screen going here. New share. Here we go. All right, so in this section, we're working with least common multiple. We learned how to use prime factorization to calculate the least common multiple. Once we finish the section, we'll go through some of the homework and see how we did. Y'all did. All right, but I'm going to start with the ladder method, finding the least common multiple of two numbers. So I'm going to use the factor ladder where it's a combined ladder so that we can kind of see them all together. All right. So let's look for the least common multiple of two large numbers. So 75 and 120. All right, so I'm going to go ahead and draw our ladder here. So we know that the smallest number, because 75 is not even, our smallest prime number is going to be 3. So 3 goes into 75 25 times. 3 goes into 120 40 times. All right, so now I think the smallest prime number that goes into these two, it's no longer 3 because neither of these, the sum of the digits equal 3. So we're going to move up to 5. 5 goes into 25 5 times. 5 goes into 40 8 times. And so now we have two relatively prime numbers. 5 and 8 do not share any prime factors. So we now have our least common multiple. And we can leave the 8 as is because that's your 2 cubed. So we have 3 times 5 squared. So in this case, again, because it's least common multiple, we end up having to use the relatively prime numbers as well. We don't just use the prime numbers that we've listed on the left side. We have to use the 2 relatively prime at the end as well. So that's why I've got 2 5, so that's why it's 5 squared. And then 8 is 2 cubed, but we don't have to break it down because we already know that we're going to include those in our least common multiple. So the least common multiple is 3 times 25 times 8. So this is 75 times 8. So 8 times 5 is 40. Carry my 4. 8 times 7 is 56 plus 4 is 6. So 600. So the least common multiple is smaller than 75 times 120. We only did 75 times 8 by doing those prime factors. And then we're left with the relatively prime numbers at the bottom. So it is the least common number, common multiple that both of these 75 and 120 will divide evenly into. So factor ladders are a particularly nice tool when we're finding the least common multiple of two numbers. Listing multiples works well for small numbers, but the prime factorization method will always work. So the primary method of finding the least common multiple and greatest common factor in most cases is always to use prime factorization. Because remember, those are like fingerprints. They are unique to each number, and so you'll always be able to find it. But this can, a lot of times, will help as well. All right, so the last thing we want to look at before we move into, we're going to work through some of the homework problems just to practice together. It's Wednesday, so we're not going to do any homework assignments tonight, but I'd like for us to get a little bit of practice with them before we move on into the review for these 3 sections. So this last one is applying what we're learning about least common multiple. These are real world scenarios, our word problems, the dreaded word problems. But to me, they make more sense because you have a scenario you're working with. All right, so in your book, this is example 4 on page 157. Andrew can run each lap around the basketball court in 24 seconds, and Levi can run each lap in 30 seconds. Assuming each runner starts at the same time and keeps a steady pace, how many seconds will it take for one of the runners to pass the other runner? So this may be something you can do in your head. Sports players are very competitive. So the one that's a little faster can be like, okay, I wonder how many laps do I have to make before I can catch up with this guy? Right. Okay. So what do we find out? So we know that Andrew can run 1 lap in 24 seconds. And Levi can run each lap in 30 seconds. So who's faster? Andrew, right. And a lot of people a lot of my students have gotten confused because Andrew's is the smaller number. So they think, oh, that, smaller number, slower, but obviously we're talking about the time it takes to travel a distance. So faster you travel it, the smaller your time will be. So yeah, so Andrew is definitely going to end up lapping Levi at some point. And so all we do to determine how many seconds it's going to take for Andrew to lap Levi is to find the least common multiple. So you can think of every trip around that basketball court as one multiple of 24 and one multiple of 30. So what we're doing is we're finding at what point they meet. All right. So when we do that, we find that the prime factorization of 24, you can go ahead and break down in the tree. Actually, I'm going to do it this way. I'm going to use the ladder. It shouldn't take too long. All right, these are both even. So 2 goes in 24 12 times, 30, 15. It's going to be a 3. Gives me 4 and 5. So yeah, so my prime factorization is all of these multiplied together. So, or excuse me, the least common multiple, 2 times 3 times 4 times 5. So this is 6. Yeah, and this is 20. And 6 times 20 is 120 seconds. So you can see how that combined tree, the factor ladder, excuse me, I never ever used it unless I was comparing two numbers. And then the combined ladder actually made a lot more sense. Okay. All right, so it's going to take 120 seconds for Andrew to lap Levi. The second part is find the number of laps that each boy will have completed at that point. So what do we have to do here?
24 times 120.
So you're asking how many laps are they doing in 120 seconds? So what are we doing? So we're dividing. Yeah.
And I found 5 for Andrew and 4 for Levi.
Right. So we take the total time before we had the lap. So for Andrew, in 120 seconds at 24 seconds. So this was what? We said 5. 5 times 4 is 20. Carry my 2, and that makes that 12. So yeah. So Andrew had done 5 laps. And Levi, I feel for Levi, man. I'd be right there with him. You know that 4 times 3 is 12. So Levi had done 4 laps. All right.
I think I did this one.
All right, so let's look at skill check C. So if you're watching the video, go ahead and pause it. Complete skill check C, see how you do, and then come back and we'll check your answers. All right, so for those of us that are here, I'm gonna go ahead and get started.
I think I did it really wrong. Because I multiplied the prime numbers that I got at the bottom to get the LCM.
And are you talking about for 4 or for all of them? Okay.
I don't know why.
Did you do the factor? Oh yeah, factor ladder.
Yeah, I did the factor.
So did you do just the bottom ones? Or all the ones on the left side and the bottom ones?
I did all of them.
So if you, I mean, like with the numbers that you multiplied.
Yeah, I only did the ones at the bottom.
So go ahead and multiply the ones on the left side as well.
Recording in progress.
All right, so let's go ahead and go through these. So if you feel like you did it wrong, now that we've worked through it together, check your answers. Did you fix it?
Yeah.
Fix it and then you can check your answer to what I get. Okay, so, okay, what'd you get?
So for number one, I think I got 350.
Lower. Okay, so let's see what you did. So what goes into 30 and 42? Obviously, when we do our ladder, we use the smallest. Try it. I can.
16 and 22.
No. 2 goes into 30, 15 times. Think 30 minutes. What's half of 30 minutes? 15 minutes. So I
Wait,
bet.
I thought the number was 36. I mean, oh wait.
Did you write it wrong?
Okay, I'm looking.
Okay.
I keep looking at number 3 at the bottom instead of number 1. Okay, I got 16, not
Yeah, that's where the mistake happened.
15
Okay.
and 22.
And 21. 2 goes into 4 2 times, but 2 goes into 2 1 time.
So it's 3.
Yeah.
So 3 can go to both of those numbers.
3 goes into both these numbers, and that gives us our 5 and our 7, which are not only relatively prime, but prime. So I'm just going to go ahead and highlight them so I don't lose them. It's the only thing about this is the structure is a little bit interesting. Okay, so for the LCM, this is nice too, because you don't have to look at the prime factorization and find like the common factor or find all the factors and then the highest exponent. You just multiply these together. So this is 2 times 3 times 5 times 7. So 2 times 3 is 6 and 5 times 7 is 35. Probably an easier way for me to do that, but actually, you know what, there is. 2 times 3 is 6 and 6 times 5 is 30 and 30 times 7. Well, that's just 7 times 3 with a 0 in the end. So that's 210. So let's do it that way.
2010.
2010? No. 210. All right. All right. So that's number. So 210 is the smallest multiple of both 30 and 42. All right. Number 2, 48 and 56. Now, what'd you get for this one?
24 and 28.
Well, would that work? Wait, 24 and 28?
Okay, so what I got for my LCM was 336.
That is correct.
Yeah.
Yes, so very good. All right, so 48 and 56 are both even. So 2 goes into 4 2 times, 2 goes into 8 4 times, 2 goes into 5 2 times with 1 left over. So we have 24 and 28. What goes into 24 and 28?
2.
2, yes.
12 and 14.
That gives us 12 and 14.
And 2 can go into both of those
Again.
which is then 6 and 7.
And these two are relatively prime. Yeah, 6 is not prime, but it is relatively prime compared to 7. So there we go. The LCM is 2 cubed, which is what?
8.
Yeah, that's 8. 2 times 2 times 2. 8 times, I'm just going to go ahead and do the 42. So 8 times 2 gives me 16. So carry my 1. 8 times 4 is 32 plus that 10 gives me 33. Yep. The LCM is 336.
And what I think I got for number 3 is 252.
That is correct. Very good. Yep, you got this. So 36 and 84 are both even. Give myself a couple of rows here. 2 goes into 36 18 times, 2 goes into 8 4 times, and it goes into 42 is 42. All right, again, they're even, so that becomes a 9 and a 21. And now we move on to 3 because these are both odds. That becomes a 3 and a 7, and we are done. So this is LCM is 2 squared times 3 squared times 7. So that becomes 4 times 9 times 7, which is 36 times 7. So LCM is 252. All right, let's do number 4. Connor mows the grass every 8 days. Okay, I'm gonna write this down. So he mows every 8 days. He washes the car. I'm just gonna put car. Every 12 days. Oh, okay, so just those 2. How often will the jobs be scheduled on the same day? So what do? We find the least common multiple of these 2. Now, these 2 are small enough and they're part of your multiples. They're your multiplication tables that you've already memorized. So you could start with the 12. So instead of breaking it down, just think of the multiples. So 12, what's 12 times 1? Does 8 go into 12? Okay, 12 times 2. So does 8 go into 24?
Yes.
Yes. So what's the least common multiple of 8 and 20 and 12? 24. Yes. So this one very easily you could do mentally, right? Now I'm going to go ahead and do the math with the factor ladder, but it's going to match what we just figured out. All right. So 8 and 12. Maybe a 3. I'm not sure. We'll see. So 2 goes into 8 4 times. 2 goes into 12 6 times. 2 can go into those again. And it gives us 2 and 3. So 2 times 2 times 2 times 3 is our LCM. So this is the first question, which is 2 cubed times 3, which is 8 times 3, which is 24. So every 24 days, he's going to be washing the car and mowing the grass on the same day. So hopefully he doesn't have homework or any other chores to do because he's going to be pretty busy. All right, so the second question was, how many times will each job need to be done within that time period? Well, 12 times what equals 24? So he's going to be washing the car 2 times within those 24 days. And how many times is he going to be mowing the grass? 3, right? 8 times 3 equals 24. So again, we already know our answer, but we can do the math. We just know if we're right or wrong, right? 2 goes into 24 2 times. So 2 times washing the car. And then 8 goes into, I know it doesn't make any sense, but we know what we're saying here. So 3 times mowing the grass. And there is skill check C. Okay. All right. So I asked you guys to do, I think, I asked you to do 2 through 24, and it included the factor ladder. So we can go through those and check our answers.
Wait, did I go over this with you?
No. All right. So
Let's just quickly go.
yeah. Let's teach you. So let's review the homework. 2 through 24 even. All right. So for number 2, what is the largest multiple of any number? Infinite. There is no largest. There is no largest multiple because the multiples are infinite. So infinite isn't the answer. It's just there are none. There is no largest multiple for any number because the numbers are infinite. All right, what about 4? List 3 ways to find the LCM of 2 numbers.
Division method, ladder method, and factor tree method.
Right, and you said division or multiplication, we call that listing, where you just list the multiples. So listing, but you're right, factor tree and the ladder method. Listing is by far the least efficient. Okay, so for these, we needed to determine whether the second number is a multiple of the first. So we compared 7 and 34. So no, 7 does not go into 34.
Number 8 and 10. For number 8, it's 4, 8, 12, 16, 22.
16, 20, and 24. Yeah, so for 8 and 10, they asked for the first 6 non-zero multiples, so those are for 4.
For 10, I got 21, 42, 63, 84, 105, and 106.
Yep, 84. Well, it's 105, but then you're adding 21 to it, so it's 126. I thought you said 106.
No.
Yeah, that
126.
that first digit, and then it becomes the hundredths place.
2, 4, 6, 8, 10.
Yeah, is 2 increased every time, and then. Okay, so find the LCM using the list of multiples. So they give you the list of multiples for 4 and for 6. And which one was the lowest common one? 12. Yeah. Hopefully that was really easy. But there we see the LCM of 4 and 6 is 12. All right, for number 14,
I got 36.
that is correct. So we have 12 and 18. And they wanted to use the list of multiples. So what are the multiples? So again, I start with 18, right? 18, 36, and I already see one that's common, but 12, 24, 36, and there's my least common multiple.
I got 72.
That is correct. So they've given you the prime factorizations for 24 and for 36. And you see that we have 2 cubed times 3, and then 2 squared times 3 squared. And again, just to review this, when you look for the least common multiple, you take all prime factors. In this case, they both have the same base, 2 and 3. But then you take the highest exponent. So the highest 2 is a 3, and the highest 3 is squared. So this becomes 8 times 9, which is 72.
And then I got 72 again on 18.
Yeah, we have a lot of 72s.
Yeah, I told you
18.
72s.
Yeah. 8.
72 for 16, 18, and 24.
Goodness. So this one, they want us to use the ladder method, which we kind of just went over, but I wanted y'all to give it a try. If it felt like how we do it, it might not be enough. We had 2, which gives us 12 and 18. 3 gives us 4 and 6. No, that's not right. Wait. No, that's 2 again. Here we go. Oh no, I got ahead of myself. There we go. 2, 6, and 9. Then 3, which gives us 2 and 3. So this is, again, 2 cubed times 3 squared, which we already discovered is 72. So for number 20 and 22, we're using prime factorization to find each least common multiple. So
For number 20, I got 84.
okay, that is correct. 28 breaks down into 4 and 7, which is 2 squared times 7. 42 is 6 and 7, 2 and 3. So what are all of the prime factors found within these given numbers?
2 and 7.
Those are the common ones. Do we need just the common?
No,
No, we
we
need all of them.
So 2,
3
3,
and
and
7.
7.
Now for 2, is there one with a higher exponent than 1?
All
2 squared. 3 and 7, only the understood one exponent, so we leave those be. So this is 4 times 3, which is 12 times 7, which gives us 84. Very good.
And for number 22, I got 1, 2, and 2.
That looks good. All right, so I think things I can probably do on my own. So 8 is 2 cubed. 12 is 2 squared times 3, so 4 times 3. And then 20 is 2 squared times 5. So for our LCM, we take all the prime factors given. So we have a 2, all the base numbers, a 3, and a 5. And then when we go back, we know that all of these 2's have exponents. We take the one with the highest. 3 and 5 have the understood exponent of 1, so we leave that be. and this becomes 8. I'm gonna do times 15. Because 8 times 5 is 40, and I carry that 4 to the 8, and I get 120, which is our answer. All right, last one, 24. Using your factor ladder for 18 and 24. Ooh, we already did that one.
72.
It is 72. 18 and 24. All right, they're both even. So do a 2. It gives me a 9 and a 12. 9 is not even, so I have 3. Gives me 3 and a 4. Those are relatively prime, so I'm done. I do know that 4 is 2 squared. So I'm just going to go ahead as the LCM. It's 2 cubed times 3 squared. We have already discovered is the prime factorization of 72. All right, that's it. Then we'll go ahead and wrap that up. We'll start the review for this tomorrow, God willing. I'm running a little bit of a fever, so I'm leaving. And I may or may not be back tomorrow. But if I'm not, we'll maybe at least do a video in class. But thank you very much, and I'll see y'all tomorrow.